Oh, you all had already come back. So let's. These are so focused. Yeah. Who is this one who always attacks my presentation? Now, oh, sorry. Yeah, don't worry with my lots of water. It's very hot here, above 27 degrees. Any question?
Sure.
Yes.
Repeat the combined events on the types of probability.
Okay. So, combined events. Let's. So, let me just use the board for the time being as we wait. Now, so combined events. What happens is, let's say you are having, you are tossing a coin while at the same time tossing a dice, okay? Or let's say you are tossing two dice. So you have dice one. Dice one has 1 up to 6. 1, 2, 3, 4, 5, 6. Then you have dice 2. 1, 2, 3, 4, 5, 6. Okay, this is quite a very big, whatever it's called, what sample. But when you toss a dice, there's a case where you'll have 1 and 1 on top. So dice 1 will have a 1, dice 2 will have a 1. Then you can get a 1 from dice 1 and a 2 from dice 2. Let me use a smaller sample so that you can easily see this. So the smaller sample would be, let me use a coin. Coin is easier. So coin A, you have head or tail. Then you are tossing two coins at the same time, coin B. You'll have a head or tail. Now, if you toss 2 coins at the same time, so there's a possibility of you getting a head from coin 1. Let me just do this. So you're tossing coin 1 and you're tossing coin 2. It's not the best. So you can get a head and a head. So coin 1 has a head, coin 2, coin B has a head. You can get coin 1 with a head and coin B with a tail. You can get coin 1 with a tail and coin B with a head, or you can get coin 1 with a tail and coin B with a tail. So these are combined events, okay? This is when you are tossing two coins together. Those are combined events. Then we went further and looked at mutually exclusive events. So for mutually exclusive events, we say that if event A occurs, B will not occur. So let's say you toss a coin for the first time and it's a head. So if you obtain a head, of course, you cannot get a tail. So this one will just be, you can only get a head. So if you have, it can just be probability of a head or, or a tail. So this will be probability of head plus probability of tail, which should be 1 because they are mutually exclusive. So mutually exclusive means if one event occurs, the other one the other event does not occur. Now for independent events, that is quite different. So independent will have will say that the occurrence of one event does not affect the occurrence of the other. And this, for example, is you have so you have a like head, you toss your coin head and tail for the first time. So even if the first time it was a head, when you toss it again, you can still get a head or a tail. Still, you can get a head or a tail when the first event was a tail. So you see, this event and this one are independent events. So this one will be probability of head and head. Let me just mute participants. So this will be, so this will be head and head. So these are independent events. So what you can be able to see from the tree diagram, for example, is these events are independent events, or head and tail are independent events. Okay. What you can also see is that head and head, this one, sorry, let me use the second one. So head and tail are what we call now the mutually exclusive events. Because occurrence of one, so if a head occurs, the tail will not occur. So if you toss your coin and you have a head, you're not going to see a tail instead. So you can only see either a head or a tail. So that's why we have the probability of getting a head or a tail, which is probability of head plus probability of tail. Is that a little bit clearer? Does that make sense now?
Yes.
Okay. Yeah. So let's just return what you were. Any other question or concern? So we don't have any other question. That's okay. Now, so we had gotten here and we were looking at this case where now you need the probability. So a boy throws a fair coin and a regular tetrahedron with 4 of its faces marked 1, 2, 3, 4. So probability of getting a 3 on the tetrahedron and a coin. So I told you that this is the space for tetrahedron. This is the sample space. And the sample space for a coin, of course, will be just a head and a tail. So we are saying the probability of getting a head is a half for a coin. The probability of getting any here in the tetrahedron is 1 over 4. What did I just write here? It's 1 over 4, sorry. So in this case, we want the probability of getting what? A head and a tetra and a 3 on the tetrahedron, which was given by probability, because these are independent. Getting a head on the coin does not affect getting a 3 on the tetrahedron, because you can still get a head and get a tail and get a 3 on the tetrahedron. So they do not depend on each other. So it's the probability of a head and a 3 on the tetrahedron, which will be given by probability of a head times probability over 3. So the head is half and a 3 is 1 over 4, which gives us 1 over 8 as your probability. This is always one of the most interesting questions, and it's very common. They say a bag contains 8 black balls and 5 white ones. So black and white balls. Then if 2 balls are drawn at random from the bag, one at a time. Remember, this is a very important part of the equation. One at a time find the probability of drawing a black ball and a white ball without replacement and with the replacement. So you're you're drawing two balls one at a time. One at a time means you pick the first ball. After you pick it, then you pick the second ball. You don't pick two of them together. So the probability, so you have 8 balls, 8 white and 8 black and 5 white. So the total number of balls here will be what? Oops. Not writing. So, okay, that looks so bad. So the total number of balls is 8 plus 5, which is 13. So if you pick the first time and you obtain a black ball, so if you're picking the first time and you're obtaining a black ball and a white ball, so the probability of getting a black ball and a white ball without replacement will be, the first time you pick, let's say you get a black ball. So the black ball will be 8 over the total number of balls, which is 13. But they're independent events. So the second time you pick, you've taken one ball already. So it is without replacement. That means the total number of balls remaining are 12. So now that you have 12 balls, then you pick now the second ball, and it's a white ball. So it's a black ball, then white ball. So the white ball will be remaining with 5 white balls, but the total number of balls will be 12. Okay, it will be 12. So this one you can simplify further. 4 here is 2. 4 here is 3. So this will be 10 over 69. So you have your probability of picking a black ball and a white ball without replacement. So that is what they have said. There are only 2 ways of getting a black ball and a white ball. So either you draw white and then black, or black and then white. So in this case, they have said white. These ones have started with white followed by black. Okay, they're cheating you. It's the black is the one that is 8. So this is black followed by white. Now let's look at the second case with replacement. Let's say you pick. Okay. Why are they doing this way? Doing it this way. So if you start with white and then black, so the probability that the first ball is white, of course, will be 5 over 13, okay? Then the probability that the second ball is black balls are 8, but you have picked one white, it will be over 12. Your answer will still be what? So 8, 2, 4 here is 2, 4 here is 3. It will still be 10 over 69. So whichever order you decide, so because they have not told you the order. If they said respectively, then you know it's black, then white, but they have not said, so you can start with white, then black, or black, then white. But correct this one is black followed by white, what they have done. Then the second part is with replacement. So if you're picking them with replacement, that means you have a black ball, then followed by a white ball. So the black ball is the probability of picking a black ball and a white ball. So the probability of picking a black ball is 8 over 13 times the probability of picking a white ball. So with the replacement, that means if you remove one ball, you return another ball there. So they remain 13. So then the white ball will be what? 5 over 13. This is the one with replacement, which gives us what? 8 times 5 is 40. 13 times 13 is, what is 13 times 13? I'm seeing someone in the chat here. Oh, yeah. Thank you. It's 39, not 69. Asante. These stories are multiplication sometimes. It's not so it's, sorry, this is 10 over 69. Our screen is hanging. This is 10 over 39. Same to this one. So this is 10 over 9. So 13 times 13, what is the answer? Open a calculator and then, what's that? Is it 169? 3 times 3 is 9. Has someone responded with the answer? Good. It's 169. Thank you. So 169. I would have chosen to use the screen. Okay, so I think we are all there. I don't know, what are you seeing on your screen, though? Are you all seeing what I'm sharing? It seems I've lost control of my screen. Any person who can are you able to see the content of the screen? So we've done that. We've been able to do, so the first part of this question is the independent events. The second part, there's a note here on this material. Oh, nice. Thank you, Kevin. There's a note here on this material that says, two events are mutually exclusive, therefore, white followed by black or black followed by white is equals to white followed by black or black followed by white. Those are just gimmicks that you can be able to deal with. Yeah, but let's say someone asks you a question that find the probability that a white ball is followed by black, or a black ball is followed by white. So you are able to do white followed by black, so white and black, which we got the answer, Paleju. Then black and white, which we got the answer. I don't know what this guy is trying to do, but yeah, these are the values. These are the real values here without replacement. With replacement, sorry, with replacement. Okay, so those are some of the things that you need to know. Let's just try to wind up this one quite quickly. And I hope we are really adding value to this work. Kamau and Njoroge and Kariuki are practicing archery. Archery ni kutupa mshale, if I'm not wrong. The probability of Kamau hitting the target is 2 over 5. Then that of Njoroge hitting the target is 1 over 4. And that of Kariuki hitting the target is 3 over 7. So we have all these people. We have Kamau, we call him Kama. Probability of Kama hitting the target is 2/5. So let's go to indicate what is in your question so that you know the tools you have. And probability of Njoroge, Mr. Njoro, hitting the target is 1/4. And the probability of Kariuki, we call him Kiki, hitting the target is 3/7. So you have those probabilities. Then now you can be able to see. So of course, probability of Kamau not hitting the target is 1 minus that. So find the probability that only once one hits the target. Okay? Find the probability that only one hits the target. That is quite interesting. So that means is the probability that if Kamau hitting the target, let me just, I don't know, let me reduce this symbol so that to make our work easier. So let's say the probability of Kamau, oops, what just happened? Let's say the probability of Kamau hitting the target with, then we have Njoroge, and you simpler letters. So the probability of Kamau hitting the target, let's call him A. The probability of Njoroge hitting the target, call him B. Then the probability of Kariuki hitting the target, call it C. So of course, oops, what just happened? Of course, the probability, hey, na jamaa hapa ananiattack vibaya sana. Of course, now where have we taken our lesson? Where is probability? It's here. Sorry for that, guys. Sorry for that. I'm sorry for the person trying to jeopardize our session. So from here, we can have the probability that Kamau does not hit the target is 1 minus 2/5, which is 3/5. Then the probability that Njoroge does not hit the target is, B. So let me just be a nice person. So 2/5, 1/4, and 3/7. So we have the probability that Kamau hits the target, we said is 2/5. And of course, the probability that he does not hit the target is 1 minus 2/5, which is 3/5. Then we have probability that Njoroge hits the target, so we call it PB, is 1/4. And probability that Kiki hits the target, we call him C, is 3/7. So of course the probability that Njoroge does not hit the target is 1 minus 1/4. It's 3/4. And Kiki is that does not hit the target is what? 1 minus 3/7. It is 4/7. So you have your probabilities. So the question that is asked here is, the question asks you, they say, find the probability that only one hits the target. Only one hits the target. Only one hits the target. So that means if only one hits the target, that will be the probability that Kamau hits the target and Njoroge does not hit the target, and that Kiki does not hit the target. Or the probability that Njoroge hits the target and Kamau does not hit the target, and Kiki does not hit the target. Or, sorry, this is just B prime, B. So, I hope tunaenda pamoja. Then, or the probability that Kiki hits the target or Kamau does not hit the target, and and Njoroge does not hit the target. I hope we are able to see that. So only one hits the target. So it can only be Kamau hitting the target. So if Kamau hits, the rest do not hit the target. If Njoroge hits, the rest do not hit the target. If Kiki hits, Kamau and Njoroge do not hit the target. So how do we calculate this one? So that is A. So the first one will be Kamau hitting the target is 2/5 times, where is the other one? So Njoroge not hitting is 3/4 times Kiki not hitting is 4/7. All of course will be plus. Kamau hitting, Njoroge hitting is 1/4. Kamau not hitting the target is 3/5. Njoroge not hitting the target is what? Is 4/7. Sorry. Njoroge not hitting the target is we are on Kiki. Sorry, come on. Kariuki is 4/7. I hope we are right there. And then finally, if it's Kariuki hitting the target, it's 3/7. Then Kamau not hitting would be 3/5. Kamau short form is Kama or Kamale, all those. Then finally, B will be Njoroge doesn't hit the target is 3/4. So 4 times 5 is 20. 20 times 7 is 140. So the denominator is 140 for all those. So this will be the first one will be 2 times 3 is 6. 6 times 4 is 24/140. So that will be 24/140 plus. Hii lesson imekuwa mrefu, poleni. 3 times 4 will be 12/140. 12/140. I hope we are right with the calculation. Then finally, it's 3 times, this is all 3. 9, that is 9 times 3 is 27/. Yeah, so we are just finishing this one here in less than 10 minutes. So 24 plus 12 is what? That is 36 plus 27, 13, 5, 6. So this one gives you 63/140. Of course, 7 can go to 63 how many times? 9. 7 into 140 is 20. So you have 9/20. In fact, some people will put it as a percentage, as we've said, and that will be 45%. I see someone is on the chat. Let me see what they're saying. Yeah, you can simplify. So it's still okay. I just wanted to have a common denominator so that you just get through it. But yeah, you can simplify. Yeah. Next, part B. So part B nasema nini? Part B nasema all the 3 hit the targets. So all the 3 hit. This is what these people have done. So you see, they have gotten the same answer like we have. Then all the 3 hit the target is this one. So let's just do that on the other side. All the 3 hit the target. And then part C is none hits the target. So probability that all three hit the target will be irregular in social macho. So it will be probability that Kamau and Joroge and Kiki hit the target. So Kamau hits the target. I don't remember the values. Is 2/5, 1/4, and 3/7. 5, 1/4, 3/7. So all the three hit the target. This is what? This is 6/140. Oh, this can still be simplified as 3/. Then next is none hits the target. So probability that none target is probability that does not hit the target and the rocket does not hit the target and it does not hit the target, which is 3/5, 3/4, and 4/7. 4. So this one will be, because 4 and 4 can cancel, 9/35. Then finally, let's look at the final question, final part of that question. Sorry, I might not be able to go to the tree diagram, but I think I will send you a video with a tree diagram, which I already recorded. It's already on YouTube. Then at least one hits the target. So this is a very interesting question. So 2 hits the target in Itawachia. I will send you the notes. But at least one hits the target will be, this one will be, where is it? Yeah. So this one, you will look at it yourselves. At least one hits the target. This is always a very important formula. 1 minus none hits the target. So let me just explain that here. At least one hits the target. So probability that one hits the target is probability of 1 minus none hits target. Always note this, because in a case where none has hit the target, that means, as in when no one hits the target, in all other cases apart from this, at least one person will hit the target. So probability, this one will just be 1 minus probability that none hits the target, which we have gotten here, is 9/35. Okay, 9/35. So 1 minus 9/35. 35 minus 9 is 26. So that is 26. I hope that is clear. Always note this. When you just see at least one does something in probability, just take 1 minus none, and then you will be able to obtain that probability. Because that means, let me just show you in long form. That means that Kamau, it will be the probability that Kamau, Joro, and Kiki hits the target, or probability that Kamau, Joro, and Kiki does not, or probability that Kamau, Joro does not, and Kiki, or probability that Kamau does not, Joro, and Kiki, or probability that Kamau and Joro but Kiki hits, or probability that Kamau, Joro does but Kiki doesn't. So it is longer to do this than just take 1 minus 9. So I hope that has been a fruitful session, and you've really understood how to handle these probability questions in an exam. Most of them, sometimes they are 10 marks, and those are free marks. So finally, you will get to use tree diagrams, which if you have a question, just reach out to me in the group. I will be able to explain how to use tree diagrams to be able to solve these probability problems. So like, so a tree diagram allows us to see all the outcomes of an event and their probability, okay? That is the role of a tree diagram. It allows us to see all the outcomes of an event. So it's good for us to see a toss. So when you toss a coin 3 times, you will have such a tree. So the first time, head or tail, half, half. Then like that until you get to the third time. So it's, from the tree diagram, we can be able to see that there are 8 possible outcomes. Of course, we have 8 possible outcomes, head, head, until we have tail, tail, tail. So those are 8 possible outcomes. This is tail, tail, head. This is tail, head, tail. This is tail, and so on and so forth. So those are the 8 outcomes they are talking about. So that is our sample space. And the sum of probabilities from any set of branches is always 1. Remember that. So set of branches, like if we take this one and this one, their sum should always be equal to 1. Same thing to this set of branches, the sum should be equal to 1. And same thing, any set of branches, the sum will always be equal to 1. So always remember that in your tree diagram. So I think you've noted that. Now, like they want you to get the probability of getting 3 heads. So probability of getting 3 heads is in the first line, head, head, and head. So that will be a half. Those are independent events times a half times a half. That's the probability of getting 3 heads, which is 1/8. Okay. Then you have probability of getting 2 heads and a tail. So 2 heads and a tail. So here you have head, head, tail. Here you have head, tail, head. And here you have head, tail, tail. So 2 heads and a tail, of course, you'll have this one, which is 1/8. If you take 1/2 times 1/2 times 1/2. Here you also have 2 heads and a tail, which is 1/8. Here you also have 2 heads and a tail, which is 1/8. So